A warm welcome to all of you people, those who are watching this video. So, in our first session of problem solving, we have proved that E is irrational, and I have told you that I will share you two kind of methods to prove that E is irrational. So I said that the method which I have shared in last session, that is quite easy to understand and a bit lengthy, and I have introduced squeeze theorems and some consequences related to limit, and we have proved that E is irrational. But there is another way to prove that E is irrational. So let me share you that things also. So this is the second part of showing you or prove that the E is irrational. So suppose that E is rational. This is our claim, that E is rational, that is there exists a comma b which belongs to a positive integer, okay, with equals to a by b, okay, where b not equal to 1. Since we have know that e is not an integer, okay, so in particular b is greater than or equal to 2 in natural set of natural numbers, okay, so we can write that so x equals to b factorial e minus summation over n equals to 0 to b is 1 factorial. Okay, so we'll show that this x is an integer with this open bound 0 to 1, which cannot happen simultaneously. Okay, so how to do that? So what we can do is that so let's b factorial, so e equals to a by b, so that is a by b minus sum over n running to 0 to up to b and 1 by n factorial, right? Now so we can write that a times b minus 1 factorial, okay, minus b factorial sum over again n running to 0 to up to b 1 by n factorial, okay. Now okay, so let's take the b factorial in the under the summation. So let me write it as sum over n running 0 to up to b factorial by in factorial. Good. Now, so we'll expand this sum in next step. So a by b minus 1 factorial minus b factorial by 0 factorial plus b factorial by 1 factorial, and that is up to b factorial by b factorial. Okay, so this shows that x is an integer since each term in the last sum is an integer. Okay, so as x is greater than 0, okay, e can be represented as this sum over in 0 to up to infinity 1 by n factorial. Now you see that if I write this expression where n running to 0 to up to b 1 by n factorial, so here this is greater, okay, where in 0 to up to infinity, and you know that, and it is obvious that this is greater than, okay. So for any value of b, okay, so any value of b, thus for any value of b, what we can write, x equals to b factorial e minus sum over n equals to 0 to up to b 1 by n factorial. This terms is definitely positive, okay. And finally, as I said that we will show that x is an integer with this bound, so we'll show that x is an integer since okay, integer with x is between 1 and 0, okay, which cannot happen simultaneously, okay. So this is our motive, okay, which cannot happen simultaneously okay. So this is our main motive actually, to show that. So yeah, so yeah, as you said that as you seen that this b factorial and this expression is so this expression is greater than 0, that means it's a positive term. So what we can write is that, so we have to next show that x is lesser than 1, okay. So you observe that, so you observe that e minus this term, okay, n equals to 0 to b 1 by n factorial, which is also be written n equals to p plus 1 to infinity, where this, so both are same, right? Now what we can write, so we can now easily deduce that so we can deduce that what we can deduce, yeah, so x equals to b factorial e minus sum over n equals to 0 to up to b, sorry excuse me. So x equals to b factorial e minus sum over n equals to 0 to up to b, b 1 by n factorial. Okay, now we can write that b factorial times sum over n running b plus 1 to up to infinity, okay, by 1 by n factorial equals to sum over n equals to b plus 1 up to infinity, that is, we will take this b factorial into under the summation, okay, and now we'll break this, we will expand this, okay, so now 1 by b plus 1 plus 1 by b plus 1 times b plus 2, okay, plus that is up to infinity, so which is obviously lesser than or equal to 1 by b plus 1 plus 1 by b plus 1 square, and so on, that is up to infinity. So we can deduce it as sum over n running up to 1 to up to infinity 1 by b plus 1 to the power n, where you can say that r equals to 1 by b plus 1 and this is lesser than 1, right? Therefore we can conclude that, so we can conclude that x is lesser than or equal to n equals to 1 to up to infinity 1 by b plus 1, okay, raised to the power n, and we can if you simplify it you will get 1 by b plus 1 by 1 minus b 1 by 1 by b plus 1, which is nothing but 1 by b, and this is lesser than or equal to 1 by 2, and this 1 by 2, but I mean half is lesser than 1. So since b is greater than or equal to 2, therefore it must be the case that E is irrational. So therefore it must be the case that E is irrational. So we are done. So this is one of the way to prove that is irrational. So thank you. So next session we'll meet again with another problem. So thank you for this time being.